Hi, this is Teacher Gerlin and welcome again to Math Habit. So in this video, we're going to discuss the rectangular coordinate system or Cartesian coordinate system. So what will be our learning objectives? Learning targets. First, define the rectangular coordinate system. Second, plot the given ordered pairs in a Cartesian coordinate plane. Third, find the ordered pairs that satisfy a given equation. And fourth, graph the equation of a line. First, let us go back to the concept of a number line. The number line is called one-dimensional coordinate system. When we say coordinate, it is referring to location. Therefore, a number line has only one location. That is why it is called one-dimensional coordinate system. So why do we have one location in a number line? Because we can only move it from left or right. Now, in a Cartesian coordinate system, we have two sets of number line perpendicular to each other. And we can now move it from up or down. Therefore, the Cartesian coordinate system is two-dimensional system because it has two coordinates. Just a quick history, the French mathematician and philosopher René Descartes, 1596 to 1650, introduced the coordinate system to show how algebra could be used to solve geometric problems. Now let us define Cartesian coordinate system. So Cartesian coordinate system is used for graphing in number pairs. It is also called a rectangular coordinate system. So the horizontal line is called x-axis and the other term for it is abscissa. And then the vertical line is called the y-axis and the other term for it is ordinate. And then the point of intersection of these two number lines is called origin. And we have four regions: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now let's discuss the four region further. So we have table here and a Cartesian plane. For instance, point A is 5 and 3 and it is located to quadrant 1. Point B, ordered pair 2 and negative 1, located to quadrant 4. Point C, ordered pair negative 2 and negative 3, located to quadrant 3. Point D, ordered pair negative 4 and 2, located to quadrant 2. Intercepts. X-intercept where the line intersects the x-axis. Y-intercept where the line intersects the y-axis. In other words, intercepts are the points touches the y or x-axis. Graphing a horizontal line. For instance, graph y is equal to negative 3. Since y is always negative 3, there is no value of x corresponding to y is equal to 0. So the graph has no x-intercept. The y-intercept is 0 and negative 3. The graph in the figure below shown with a table of ordered pairs is a horizontal line. For instance, point 2 and negative 3, point 0 and negative 3, and negative 2 and negative 3. As you observe, the 3 points in the table form a horizontal line. And as you observe again, there is no point touching or located here in the x-axis. Therefore, if the equation of a line, the x is equal to 0, or the x has no value, the graph is always horizontal line. Graphing a vertical line. For instance, graph the equation x plus 2 is equal to 5. The x-intercept is 3 and 0. The standard form 1x plus 0y is equal to 3 shows that every value of y leads to x is equal to 3. So, no value of y makes x is equal to 0. The only way a straight line can have no y-intercept is if it is vertical, as in the figure below. So, we have the table here, the ordered pair 3 and 2, 3 and 0, 3 and negative 2. So as you observe, the 3 ordered pairs in the table form a vertical line. And there is x-intercept here, which is 3 and 0. And there is no point lying on y-intercept. There is no point here because there is no value of y that makes x is equal to 0. Therefore, if the equation, the value of y is equal to 0, the graph of the equation is vertical line. Graphing a line that passes through the origin. Graph the equation 3x plus y is equal to 0. So we find the x-intercept by letting y is equal to 0, substituting the value of y, which is 0, to the equation, then solve simultaneously. So the answer is x is equal to 0. X-intercept is 0, 0. Another, we find the y-intercept by letting x is equal to 0. By substituting the value of x, which is 0, to the equation, then solve simultaneously, the answer is y is equal to 0. So y-intercept is 0, 0. Both intercept are the same ordered pair, 0, 0. This means the graph goes through the origin. Graphing a line that passes through the origin. Graph the 3x plus y is equal to 0. Since this equation 3x plus y is equal to 0 is passing through the origin, the first ordered pair is 0, 0. So, to find another point to graph the line, choose any non-zero number for x. Say for instance, x is equal to 2 and solve for y. Let x is equal to 2. So 3x plus y is equal to 0. Substitute the value of x to the equation. Solve simultaneously. That gives us y is equal to negative 6. So the ordered pair is 2 and negative 6. So here it goes. The graph of 3x plus y is equal to 0. So the ordered pair or the points are 0, 0 because the equation 3x plus y is equal to 0 is passing through the origin. And then the other point that we solved a while ago is 2 and negative 6. Lead to the graph shown below. So we have 0, 0, which is the x and y intercept, and then 2 and negative 6. So we draw a straight line here. So it shows that this line is the graph of the equation 3x plus y is equal to 0. As a check, verify that 1 and negative 3 also lies on the line. So we have point 1 and negative 3. So point 1 and negative 3 is also lies on the same line. Now, let us check what you have learned in this video lesson. So get your activity sheet and try to solve the following. Page 3, practice 1 and 2. Page 5, practice 3 and 4. And then page 6, the post test. Thanks for watching!